the bottom of page 469, they draw a circle, and this circle has a radius of 1. The first thing we're going to do is we're going to highlight what this is called. This is called the unit circle because its radius is 1 unit, so its name is the unit circle. And this is where life gets crazy because trigonometry up until now involved triangles, right? And now we're going to start to see how we can use trigonometry on circles. Now, it's a little bit of cheating because it still uses triangles. For example, on the unit circle, if I take a random point, and they have one labeled right here, that random point you can go straight down and straight across, and with the radius of the circle, make a right angle triangle. And that random point has an x coordinate and a y coordinate. Okay? Now, if you did your trigonometry for this triangle, and you called this angle here theta, could you tell me what sine of theta is? Sine, SOHCAHTOA, sine is the opposite side over the hypotenuse. So my opposite side is y. My hypotenuse is 1. Oh, and y divided by 1 is just y. Similarly, I could do cos of theta. My opposite side is, adjacent side is x. My hypotenuse is 1. And so it's just x. And what we're going to do is we're going to start here. On page 470, at the bottom you have a little bit of space. You're going to write the 3 big ideas for this unit. Okay? We're going to get ready for big idea number 1, but we're going to turn back to our diagram here to discover big idea number 1. If I pick any random point on here and it has an x comma y, and I just drew the circle and I just figured out that x is equal to cos of theta and y is equal to sine of theta, we can now write any point on the unit circle instead of x comma y, I can write as cos theta comma sine of theta. This is big idea number 1. So let's turn to the other page. Big idea number 1 is points on the unit circle. Cos of theta is your x coordinate. Sine of theta is your y coordinate. And your minds right now should be like exploding with awe because this is really quite astounding. Why is it quite astounding? Well, you can now do some mental math that you never thought you could do before without your calculator. What is sine of 270 degrees? Nope. Right? Your minds are like, I have no idea. It's not a half sine of 270. Well, where is 270 degrees in standard position? 90, 180, 270. At 270 degrees, do you see that I would have this point on my unit circle? What are the coordinates of that point? 0 for the x-coordinate. And the radius is 1, so that would mean -1 for the y-coordinate. And what did we just learn as a first big idea? Coordinates on the unit circle can also be cos of theta, sine of theta. But if I went all the way to here, then my theta, or my angle, is 270 degrees. So now, without your calculator, what is sine of 270 degrees? Big idea says sine is your y-coordinate. It's -1. Try it on your calculator. Sine of 270 degrees. It will come out -1. You can now do any axis really quickly, right? What's cos of 0? Well, this point is 1, 0. Cos of 0 degrees would be the x-coordinate, would be 1. This is big idea number 1. The equation of a circle is just the Pythagorean theorem. Any point that's on your circle follows x squared plus y squared equals 1. 1 squared, but 1 squared is 1. Would you agree that that's true? Right? I can make Pythagorean triple a squared plus b squared equals c squared anywhere. Any point that's on the circle will have an x, a y, and a radius of 1. So this is the equation of a circle. But if the x is just cos and the y is just sine, can you see that we could rewrite this as cos of theta squared plus sine of theta squared equals 1? Because the x is cos on the unit circle and the y is sine on the unit circle. Now, mathematicians are lazy inherently. They like to write as little as possible. Things in particular that bother them are brackets. So this formula is on your formula sheet. Even though when we write it as x and y, we always write x first. For some reason on your formula sheet, when they have cos and sine, sine is always like the favorite trig function. Do you know what you call all trig functions together? Sinusoidals. They don't call them tangentoidals or cosinoidals. No, they have the word sine in them. So on your formula sheet, this same formula is written with sine first, and mathematicians don't like writing the brackets, but what's the problem if I take the bracket away? How do you tell? Does this mean the whole thing is squared? Or does this mean just the angle is squared? Right? It's problematic. So they said, okay, we have a way to get rid of this problem. We will say this one means this. And if we want the whole thing to be squared, we will write it like this, with the squared before the theta. Isn't that weird? Well, it's not weird to me because I've seen it for so long, but that means the whole thing squared, and then we don't have to write brackets, which makes us a little bit lazier, and we're happy. So we say sine squared of theta plus cos squared of theta is always equal to 1. This works for any angle as long as the angle is the same. Mental math, 13 degrees. Sine of 13 degrees. Right? Put that into your calculator, you get like 8 decimal places. Memorize that. In your head, square it. Then take cos of 13 degrees and square it. Take both of those answers and add them together, you will always get 1. Which is crazy. You can try. Like, non-mental math. Sine. I can't freeze as long as, what is, wow. Oh, I was also not responding there for a bit. There. Oh, there. Perfect. Sine of 13. I don't think you could have remembered those numbers. Square it. Answer squared. Boom. 0.05. Cos 13. Square that. If I take this answer that I had and I add this answer that I got, perfectly equals 1. And that would work whether I use 13 degrees, 72 degrees, 10 degrees, 8,438,605 degrees. Whichever angle I choose, as long as that angle is the same, we get that sine squared of theta plus cos squared of theta is always equal to 1. This is big idea number 2. We will use big idea number 2 so much that by the end of this course, it's kind of going to be like something you think everybody knows. For example, now that you're in grade 12, when you see other people around you, if you said, oh, a squared plus b squared equals c squared, you would expect that they would be like, oh, I know that. Would you feel weird if you ran into someone in grade 12 and you said a squared plus b squared equals c squared, and they'd be like, weird? You'd be like, I expect you to know that, right? It seems like common sense. By the end of this year, this will feel like common sense to you. Sine squared of theta plus cos squared of theta is always equal to 1. And what haven't we talked about? We haven't talked about tan. So if you went to this triangle and you wanted to talk about tan, well then tan of theta, opposite side is y, adjacent side is x. But if y is always sine and x is always cos, that means that tan of theta is always sine of theta divided by cos of theta. Did you know that? Pick any angle. But what's a number you think has been neglected in high school? 23? Okay. It's like they avoid the number 23 in questions. So we could do, if I do tan of 23 and see what answer I get, and then I do sine of 23 on the top of my fraction and cos of 23 on the bottom of my fraction, my answer perfectly matches tan of 23. And this works every single time with every neglected number and non-neglected numbers as well. That is big idea number 3. And when you're working on problems in this unit, you will sometimes get stuck, and I'll say, oh, well, maybe you can use one of your big ideas. Maybe that would help you in this question. Okay. So there's our 3 big ideas, and they're all based on the unit circle and a triangle, simple triangle with a radius of 1. We realize all of these new things. Yes? What use is the second big idea? Well, there'll be some questions that we have that you might know what. For example, if I tell you that sine squared of theta is 1/4, you now know that cos squared of theta is 3/4. Because together they'd have to add to equal 1. Okay? It's connected It's connected to the equation of the circle. And there is a whole branch of mathematics that looks at how things are equal to each other. And so knowing that sine squared of theta plus cos squared of theta is equal to 1 lets us figure out a bunch of other mathematics as well. We'll get to that. That's sort of our next unit that looks at those quite a bit. If we turn to the next page, we also have some other definitions that are going to be important. And they are our reciprocal trig functions. So in grade 10 math and grade 11 math, you learned about sine, cosine, and tangent. You learned about SOHCAHTOA. You learned the sine law and the cosine law. But there are also reciprocal trig functions, which are secant, cosecant, and cotangent. So off to the side here, I'm going to get you to write out that the definition of a secant theta is 1 over cos theta. The definition of cosecant theta is 1 over sine theta. And the definition of cotangent theta is 1 over tangent of theta. A reciprocal means just 1 over something else. Okay? It is really easy to remember, and I don't know what kind of memory techniques you use, that tangent and cotangent go together. I don't know how you're going to figure out and make that connection, that cotangent and tangent go together. That one I think is the easiest one to know that they go together. But the other ones are a little bit harder. How are you going to remember that secant goes with cosine and that cosecant goes with sine? Don't you kind of wish they did it the other way? That cosecant would go with cos? But it doesn't. Oh, just so maybe you remember that they're opposites, right? And secant starts with an S, so it has to go with cosine because it doesn't start with an S. And cosecant starts with a C, so it has to go with sine, which starts with an S. Somehow you're going to have to remember these definitions of which ones go with which. And do you remember that we had a big idea for tangent? That tangent was sine theta over cos theta? So we can use that big idea and say cotangent is the flip of tangent, so that if tangent is sine over cos, then cotangent will be cos theta over sine theta. Okay. I will end our big idea video here.